So we're going to start talking about adding and subtracting rational expressions. And again, rational expressions are just fractions. And so we have to get a common denominator before we can add numerators. And so when you're getting a least common multiple with expressions, you have this little thing here. It says find the prime factorization of each expression and form a product that contains each factor the greatest number of times it occurs in any one prime factorization. So that's a lot of words, but basically what it's telling you to do is factor the denominators, and every time you see a factor, that better be in your common denominator. And so it's not really that big a deal to do, and we're going to do a couple examples of just doing fractions so you remember what we're doing, and just with integers, and then we're going to move on to some expressions. So when you're adding fractions, you need a common denominator, and if you already have a common denominator like this, all you're doing is adding the numerators together. And so you leave the denominator what it is and add the numerators in this case, and then reduce. Okay, so it's basically the same idea. Now, of course, if you have unlike denominators that you're trying to add or subtract, you have to get a common denominator. And if you go off that definition from the last section there, it says break it down into its prime factors. So this would be 3 over 2 times 2 minus 7 over 3. And what you would be looking for is every factor needs to show up in your common denominator. So we need a 2 and a 2 and a 3 in our common denominator. And whatever you multiply the denominator by, you have to multiply the numerator by the same thing. So we're missing a 3 in this one, so we got to multiply top and bottom by 3. And the reason for that is that you can multiply anything by 1. So 3 over 3 doesn't really change anything. It just kind of gives it a different look. And then the second fraction, we'd have to multiply both numerator and denominator by 2 times 2. So then this would give us 9 over 12 minus 28 over 12. We subtract that and get 19 over 12. So we're going to use the same kind of idea, and it probably will even make more sense when we use expressions, because you can always just multiply by exactly what's here on problems like this and get there. And I think expressions will actually maybe make a little bit more sense. Okay, so this is exactly the same as the first example we did without variables. We have a common denominator here of x, so we don't have to multiply either of these two fractions by anything. We're just going to add the numerators together. So it's going to be 3 plus x plus 4, and then we're going to leave that over x, right? You never change the denominator when you're adding or subtracting. And now all you're doing is looking for like terms to combine, and we can add the 3 and the 4 together and get 7 plus x over x. And if we can simplify it, we can simplify it, but the same rules apply as when you were simplifying rational expressions, right? You can only cancel factors, and so there's nothing that we can cancel here, and so this is what our answer is. Okay, for our next example, we have the same denominator, and so we are just going to add the numerators together. And so 4x squared, we're looking for like terms, so we have 4x squared, and then negative 5xy plus 2xy is negative 3xy minus y squared, and that's all over x squared minus y squared. And now we're going to see if we can factor the numerator and the denominator to see if they have any common factors that we can cancel. So again, if you want to do this off to the side somewhere, that's fine. And so we're going to factor the numerator using the a times c method. And 4 times negative 1 is 4. And rewrite that as 4x squared minus 4xy plus xy minus y squared. and group them, take out what you can. So we have a 4x in this first group. We're left with an x minus y. We'll take out a positive y in the second group and we'll be left with x minus y. And so the numerator will factor into 4x plus y and x minus y. And then the denominator is a difference of squares. So that'll be x plus y and x minus y. And you'll see that both the numerator and denominator have an x minus y that we can cancel. And then we're left with a 4x plus y over x plus y. And there's nothing else you can cancel, so that's going to be what our answer is. Okay, so we have another problem here with common denominators, so we're not worried about finding a common denominator. We're just going to combine the numerators. But you notice that this is a subtraction problem now, and just like any other time you have a negative involved, you have to be very careful about what's going on, because we are subtracting all of this numerator. Okay, so make sure that you understand that and make sure you take care of the signs when you do that. So really, our numerator is going to be 4x plus 5 minus the quantity of x minus 2. That's all going to be over x plus 3. Remember, you're not doing anything to the denominator once they're the same. And so then I think it's a good idea to distribute that negative sign through. So it'd really be 4x plus 5 minus x plus 2. So we'd get 3x plus 7 over x plus 3. You want to check to see if there's anything that you can factor, and in this case there is not, so this is what our final answer would be. Okay, here's our first example where we don't have a common denominator, and so that's the first thing that we're going to take care of. And this one's pretty easy to see what's missing and what we'd have to do to get a common denominator. But I'm still going to write it out so that you can kind of see the whole process. And the whole process would be getting prime factored form. And so this first one we're going to write as 2 over 3 times 7x. And we're going to leave the other one alone because 3 is already a prime factor. And now we're just looking at both denominators and seeing what's missing from each. Okay? We have a 7 in this denominator, but no 7 in this one. So that means we're going to have to multiply the denominator and numerator of the second one by 7. Okay, both of them have a 3, so we're not worried about that. And then you should notice that there's 2 x's here. That's what the x squared means, x times x, but only 1 x here. So to get it common, we better multiply the first fraction's numerator and denominator by x. Okay, and so once you've decided what you're multiplying by, then do that. Okay, and just make sure that everything turns out the way it should. So our numerator in our first one is going to be 2x, and then we're going to have 21x squared in the denominator. And we're going to add that to 35 now, and 21x squared. Okay, and so if we've done it right, we'll have common denominators, which we have, or which we do. And so now we're going to leave the denominators alone, 21x squared, and then add the numerators, combining any like terms. And of course in this one there is no like terms. Always check to see if there can be anything factored in your, once you've combined your fractions, and in this case there is nothing. So then this is what our answer is. Okay, on this example, we got a lot of work to do here, and I would suggest starting off all of these problems by factoring just the denominator and then kind of seeing where that takes you. So we're going to factor the denominator here on the first fraction, and it's going to be x plus y and x plus y. And then this second denominator is the difference of squares, so we have an x plus y and an x minus y. Now, if you notice that you can cancel something early, and what I'm talking about here is if we take a 2 out of this, we'd be able to get rid of the x minus y's. And sometimes that's not a good idea, but in this case, there is no x minus y anywhere else in the problem. So if we can get rid of it, it'll make our problem a lot easier. So I'm actually going to do that. We'll have a x squared, and I'm going to write this as x plus y quantity squared, plus I'm going to factor out the 2 and have an x minus y, and an x plus y, and an x minus y. Okay, so now we're able to cancel the x minus y's and have a pretty simple problem left over. We still need to get this into one fraction, and we'll have to get a common denominator to do that. And we have 2 factors of x plus y in this first fraction, but only 1 in the second. So that's what we're going to have to multiply numerator and denominator by in the second fraction, because we need both of them. We can't just have one. They're not common denominators yet. So this is going to give us a common denominator of x plus y squared. And now I'm just going to write both numerators together, and that's a rule that you're allowed to do. Common denominators, you're just combining the numerators. And we're going to have x squared plus 2x plus 2y and now you should always check to see if you can factor. And at first glance, maybe you think you can factor this numerator, but it's not set up correctly with both of these variables in there. So this is actually as far as we can get. Now, it's not always going to work where you have something that you can cancel early. Usually, you don't want to cancel anything when you're getting when you're adding and subtracting rational expressions, because oftentimes what you cancel you end up having to bring back into the problem anyway. But it's always worth checking. You know, maybe it's going to make it easier, maybe it's not. Here's another example of subtraction. So once we get our common denominator, you have to be very careful with the second group of numerators, because they're all being subtracted, so be very careful with the sign. But again, we do not have a common denominator, so our first step is going to be factoring the denominator. So the first denominator factors into y minus 1, y minus 6. And the second denominator factors into y plus 1 and y minus 6. So you notice that both fractions have a factor of y minus 6 in them, and that's going to be part of our common denominator, but we do not have to multiply either fraction by it. But one fraction has a y minus 1 and the other one has a y plus 1. If you see it down there, it better be showing up in your common denominator. So we're going to take this y plus 1 and multiply both top and bottom of this first fraction by it. And then we're going to take this y minus 1 and multiply both numerator and denominator of the second fraction by that. So we're going to have this 2y plus 1, and we're going to multiply by y plus 1. And then we're going to have y minus 1 and y minus 6, and now we're going to add the y plus 1. And in the second numerator, we're going to have the y plus 3, and now we're going to also multiply that by y minus 1. And we'll have the y plus 1, the y minus 6, And now we'll have the y minus 1 as well. We have to FOIL both numerators, and we're going to subtract the second ones. And since we already have our common denominator, I'm only going to write it once. And so that common denominator is going to be this whole 3 factors, y minus 1, y plus 1, and y minus 6. And it doesn't matter which order you write them in, as long as they're all down there. The first numerator we're going to FOIL into 2y squared plus 2y plus y plus 1. And now we are subtracting, and so I always set it up with these parentheses to make myself remember that I have to distribute a negative 1 to everything. So when we FOIL the second numerator here, we get y squared minus y plus 3y minus 3. Okay, so I'm going to combine the like terms in each grouping here in the polynomials of the numerator, and that's going to give us 2y squared plus 3y plus 1 minus y squared plus 2y minus 3. Okay, now again, you're subtracting, so watch all your signs over here, and if you need to, rewrite them. You know, with the once you've distributed the negative 1. So that's going to look like 2y squared plus 3y plus 1 minus y squared minus 2y plus 3. And now we're just combining like terms. So 2y squared minus y squared is just y squared. 3y minus 2y is positive y plus 4. Always check to see if you can factor anything in the numerator, because ideally we would cancel something from the numerator and denominator. But this doesn't factor, so we can't go any further. And this is what you're left with. So these next couple examples are going to have to do with, you know, the signs of the denominators and what you can do when they're opposite like they are in this case. These are not common denominators because common denominators are exactly the same. And we have a negative here and a positive here. So, you know, it's pretty obvious what you need to multiply by, right? The only thing that's different is a negative sign. And it doesn't really matter which of the two fractions you choose to multiply by negative 1. We could multiply the first one by a negative 1, or we could multiply the second one, numerator and denominator, by a negative 1, and we could get the same common denominator. But I'm going to do the second one. Again, it doesn't really make any difference as long as you follow what you're doing. Follow the rules. So again, I'm going to multiply the numerator and denominator of the second one by negative 1. And that'll give us 3 over 8a plus a negative 1 over 8a. Now we do have a common denominator. And, you know, there's more than one way to write this. You know, this is fine. We have a 3 plus a negative 1. Or if you want to get fancy, you could say that this is 3 over 8a minus 1 over 8a. And everybody likes to be fancy, so you're welcome to do that. But either way of these is fine, because you're still going to get 3 minus 1, which is 2 over 8a. Now just check to make sure you're done. And in this case, we can divide, or, you know, both numerator and denominator by 2, or you can, you know, also think of it as factoring out a 2 and canceling. But either way, we're going to be left with 1 over 4a. Okay, we have another situation where we have opposites in the denominator. So I'm going to show you another way to think about this. If you look closely, these two are just opposites, right? We have a positive x in the first one and a negative x in the second one. We have a negative 2y in the first one and a positive 2y in the second one. So you're welcome to go about it in the same fashion that we did in the previous example. But another thing you can do is we can just factor out a negative 1 right here. And so it would look like this. We're not going to touch the first fraction. But then I'm going to take this negative 1 out just of the denominator. And we'd be left with x minus 2y. And so we basically have the same denominator now except for this negative 1. And if you're really up on your multiplication rules, you can multiply negative 1 anywhere you want to in this fraction. So what I would suggest to do is kind of multiply it out front, and we'd be subtracting a negative. So really we can rewrite this as 5x over x minus 2y plus 3y minus 7 over x minus 2y. Okay, so the difference from the last example is that we multiply both top and bottom by negative 1, and you can still do that. But I think it's a lot cleaner to say, well, I'm just going to take a negative out and then mess with this sign, make it the opposite. And so now we're just combining any like terms. We don't have any in this case, but we do have a common denominator of x minus 2y. And then we just have 5x plus 3y minus 7, and we are done. So you can add and subtract more than one fraction at a time, but you still need to get common denominators throughout. So I'm going to go through the same process here. We don't have common denominators yet, and so I'm going to factor this first one. I'm going to factor out a negative of this one, and then I'm just going to rearrange the third. So we would have 2x over x plus 2, x minus 2. And then, like I said, I'm going to take a negative out, so it's very similar to that last example. I'm going to factor a negative out of here, and that's going to change this plus to a minus. 5 over x minus 2. And then I'm just going to rearrange this third denominator as x plus 2. Okay, and so as you look through all your denominators, you should see that this first one has both of the factors from the second and third fractions. So this is what our common denominator actually is going to be, and we're just going to have to multiply this middle fraction here by x plus 2, both numerator and denominator, and the third fraction by x minus 2. So we're going to have 2x over x plus 2, x minus 2, minus 5 times the quantity of x plus 2 over x plus 2, x minus 2, minus 1 times x minus 2 over x plus 2, x minus 2. So now we have the common denominator. We're going to have to distribute the 5 in this second fraction and then go about combining like terms and just watch out for the subtraction signs. Okay, so I'm going to only write the denominator once so I don't have to keep redoing it. So it's all going to be over x plus 2 and x minus 2. So we're going to have 2x from the first fraction minus, and I'm going to put parentheses here to remind myself to distribute the negative 1. And we're going to have 5x plus 10 minus the quantity of x minus 2. And again, just watch out for your signs. This is going to give you 2x minus 5x minus 10 minus x plus 2 all over x plus 2, x minus 2. And now we're just going to combine any like terms. So we have 2x minus 5x minus 1x, so that would be negative 4x minus 8 over x plus 2, x minus 2. And now we're going to check to see if there's anything that we can factor. And we can take a negative 4 out of this numerator. And so that's going to look like this. Negative 4. We're left with x plus 2 all over x plus 2, x minus 2. And we're able to cancel these x plus 2's. And so after the beginning of all three fractions, we got that simplified down to only negative 4 over x minus 2.